Hi guys, welcome back to the channel. In this video I'll be looking into acid, bases and pH from the acid and bases topic from the A-level chemistry curriculum. So let's get started. So first, looking at the definition of Bronsted Lowry acid and bases. So Bronsted Lowry defined acid as a proton donor. A base, on the other hand, is a proton acceptor. It will accept the protons that the acid is donating. So what does this mean? So if we have HCl reacting with NaOH, so what happens in that? So we have the HCl donating those H plus protons there. So as you can see, we have HCl, so HCl splits into H plus and Cl minus, so we have H plus from that HCl, and from that NaOH we end up gaining OH minus. We are ignoring Cl minus and Na plus for this, just focusing on the H plus and OH minus. So what happens now is those H plus and those OH minus will react together. So the HCl has given that proton, so it's donated that proton, and that NaOH is acting as a base because it's accepting the proton that the HCl is donating. And what would happen is this would form water, and this is an example of a acid-base equilibria where there is a transfer of protons. So in acid-base reactions we don't have transfer of electrons or neutrons, it's just the transfer of protons that occurs. Alright, okay, so now looking at the acid strength. So not all acids have the same strength, different acids will have different strength. And the strongest type of acid, so the strong acids such as pH 1 and 2 will fully dissociate in solution. And just as a note, you can have pH of less than 0, so a stronger acid could have a pH of, for example, -1. That would be very strong. So what does it mean by fully dissociates? So for example, this HCl has fully dissociated into H plus and Cl minus. So for example, if at the start we had 100 HCl and we had 0 H plus and Cl minus, well, all of the HCl would have fully dissociated, so we would have end up forming 100 H plus and 100 Cl minus, and we would be left with 0 HCl. Looking at an example, for example, if our acid was called HX, and then the HX have fully dissociated, so at the start we would have HX as bonded together, but then all of these have fully dissociated, so we do not have any HX together anymore. All of them have dissociated. And now comparing that to a weak acid, so a weak acid would partially dissociate in solution. So what this means is, for example, if we had 100 of these ethanol and we were dissociating them into H plus and CH3COO minus, then for example only 10 would dissociate, so we would still be left with 90. So not all of these would dissociate, these only partially dissociate. So again, looking at a diagram, so as you can see, only one of these HX have dissociated into H plus and X minus, or all the other ones are still remaining as HX, and that's what is a weak acid. And as you can see the difference, so this usually has a equilibrium symbol in the middle, and because not all of these would have dissociated, and whereas with the strong acid we usually have that arrow. So base strength is basically the same. So strong bases would fully dissociate in solution. So for example, NaOH would fully dissociate into Na plus and OH minus. No NaOH would be left over, whereas weak bases would only partially dissociate in solution, and we would still have, for example, NaH3 left over. After the dissociation has occurred, we wouldn't fully form NH4 and OH minus. So you need to know what a conjugate acid-base pair is. So a conjugate acid is a proton donor in the reverse direction, a reverse reaction essentially, and a conjugate base would be the opposite. It's a proton acceptor in the reverse reaction. It's going to be much easier if we go through an example. So looking at this, so what would be the acid and what would be the base? So what I can see is that the HCl would be an acid because that H plus is being donated by the HCl as it forms ACl minus at the end. So that would be an acid, whereas that H2O would be a base because it's gaining that proton, as you can see there. So then what's a conjugate acid and what's a conjugate base? So to work out this, you could visualize this reaction in the reverse direction. So I could say that it's the reverse reaction occurring in the forward direction. So you could visualize it as that to make it easier for yourself. You don't have to, but you could say that now we have the reverse reaction occurring, and we're basically going to work out what's the acid now and what's the base. So looking at H3O plus, because it's now donating that proton. So as you can see, and we end up forming H2O. So this would be an acid as it's donating a proton, whereas Cl minus, because it's accepting that proton, that would be a base. So now what we could just use this information and apply it to our previous equations. So that acid from this would be a conjugate acid in the previous equation, and the base would be a conjugate base in the previous equation. This is how you can do it to help yourself. Looking at another example, so you don't have to draw the whole thing, you could just visualize it. So for example, the HNO3, because it's what I can see in the products, because it's gained that hydrogen, so that would be a base, whereas the H2SO4 has lost a hydrogen in the product, so that would be an acid as it's donating that acid. So now just looking at the conjugate acid and the conjugate base, so I can see HSO4 minus, so it ends up forming H2SO4, so it's gaining a proton, so that would be a conjugate base, and H2NO3 plus, it's donating a H plus, so that would be a conjugate acid, and this is how you would work it out. And just to remember that conjugate base pair, so we have something called a conjugate base pair, and what that is an acid or a conjugate base. So for example, if we have H2SO4 and HSO4 minus, these would be a conjugate base pair because one is an acid and one is a conjugate base. We could also have a base, so HNO3 and H2NO3 plus, so that's a base and a conjugate acid, which also form a conjugate base pair. So it's an acid, it has to be an acid, and it has to be a base that forms a conjugate base pair. You can be asked to work out the pH of a solution. So pH is basically a measure of the concentration of H plus, so the protons. And if you remember, we can write concentration in square brackets. So because it's the concentration of these H plus, we can just write H plus in square brackets, and that would be a representative of a concentration of H plus. So in an exam question, if you're asked to define pH, you wouldn't write it's a measure of concentration of H plus. You basically write how you work it out. So to define it in an exam question, you just write minus log to the base of 10, and then you would write square brackets H plus. It has to be square brackets because it's a concentration of H plus, and that's how you define pH, and that's also how you work it out. So if we were given 2 moles decimeters cubes of HNO3 to work out the pH of this, what we simply do is minus log, remember the minus, base 10, and then we would just write 2 in there, and that gives us a pH of minus 0.30. And just always remember that whenever you ask for a pH, you give it to 2 decimal places. You'll be penalized if it's not 2 decimal place. And I've chosen this example on purpose because a lot of people think that when they gain on any pHs in minus, they think, oh, the pH only goes from 1 to 14. Just to remind you that there can be acids strong as less than 0. So you could have, for example, in this case we have minus 0.3, and also really strong bases which can be over 14. So it can go up to 14.2. And so if you end up getting that, don't think that it's wrong. So now looking at a slightly harder example, so we're being asked to calculate the pH again, and this is when we add this is the pH when we add 100 centimeter cubed of water to 50 centimeter cubed of HNO3. So whenever we are adding something to something, what we usually do is work out the moles. So we need to work out the moles of the acid first. So that would be moles equals the concentration times the volume. So remember, volume would be in decimeters cubed, so that would be 0.05 decimeters cubed times 0.1, and this gives us 5 times 10 to the minus 3. So I know that because HNO3 is a strong acid, it will fully dissociate. So what this means is, because in this HNO3, so we have 5 times 10 to the power of minus 3 moles of HNO3. So all of this would dissociate into H plus and NO3 minus. So that means that the concentration of our H plus will also be 5 times 10 to the power of, I don't mean the concentration, I mean the moles would be 5 times 10 to the power of minus 3. So that's the moles of HNO3. So now we need to work out the concentration of it, because remember that pH is, we need to work out the concentration in order to work out the pH. So then what we would do is we would, so concentration is moles divided by volume. So we would just divide this by volume, and volume we would add 100 from the water to the 50 which is in the acid, and that would give us a volume of 0.15 decimeters cubed, and that gives us a concentration of 0.033 recurring. And then we could sub that into our equation of minus log base 10, and then sub in the concentration, and that would give us a pH of 1.48. And this is how you would approach this type of question. You can also be asked to work out the concentration of H plus when you're given pH. So you would do the opposite. So instead of doing minus log to the power of that, you would do H plus is equal to 10 to the power of minus pH. So looking at an example, if we are given that HCl has a pH of 3.55, to work out the concentration we would do 10 to the power of minus 3.55. So in this case it would give us the concentration of 2.82 rounded up to the power of 10 times 10 to the power of minus 4 moles per decimeter cubed, and that would be our concentration of H plus. So you can also be given neutralization calculations and work out an asked to pH. And this video will be only looking at its concentration in excess, but you can also have the OH minus concentration in excess, and there's also buffer calculations which we'll be covering after. For now, we're being asked to work out the pH when we've been given the concentration in volume of HNO3, and we give also the base, which is BaOH2. So what we would do at the start is work out the moles of our acid and base, and then work out the moles of H plus and OH minus. So first, working out the moles of our acid, we have HNO3. So again, concentration times volume. So the volume has to be in decimeters cubed, and that would give us 0.065 times 0.075, and this just gives us a concentration, moles, 4.875 times 10 to the power of minus 3. So if I look at the formula of HNO3, I know that for every acid, every 1 mole of acid I will have every 1 mole of H+. So this means that the concentration of H+ will remain the same, and that will be 4.87 times 10 to the power of minus 3. So now working out the moles of my base, which is BaOH2. So that would be 0.03 times 0.05, and this gives me 1.5 times 10 to the power of minus 3. This is the moles of my base, but then I need to work out the moles of OH minus, because it will be ultimately H plus which will be reacting with OH minus. So what I see when I look at the formula of my base, that for every 1 mole of base I will have 2 moles of OH minus, because as you can see I have OH2 there. It's not just BaOH, it's BaOH2. So what I would do is times the moles of base by 2 to work out the moles of OH minus I have. So I would just do 1.5 times 10 to the power of minus 3 times 2, which just gives me 3 times 10 to the power of minus 3, and this is the moles of my base. So then I would work out if it's acid or if it's base in excess. For this it would be acid in excess, because we have 4.875 times 10 to the power of minus 3, and then 3 times 10 to the power of minus 3. So I would work out how many moles I have in excess of this acid. I would just do 4.875 times 10 to the power of minus 3 minus 3 times 10 to the power of minus 3, which just gives me 1.875 times 10 to the power of minus 3. This is the moles of H plus in excess. So this is what we use to work out our pH. So we've got our moles, and now we need to work out our concentration. So concentration, again, it's moles divided by volume. So we have 1.875 times 10 to the power of minus 3. And now our volume we need to work out. So we have 65 centimeter cubed and 30 centimeters cubed. So if we add them and turn them into decimeters cubed, we would just get 0.095, and the concentration ends up being 0.0197 moles per decimeter cubed. And then what we would do is at the end minus log this base 10, 0.197, and we get our pH, which would be two decimal places, remember, 1.70. Thank you so much for watching this video. If you did like this video, don't forget to subscribe to see more of these, and you can watch my recent videos by clicking on the links popping up. Thank you.